Problem 6. Use symbolic methods to solve the inequality. Describe a solution set as an inequality in interval notation and in a graph. Then use graphing calculator, tables, or graph to verify your results. Let us take a look at this inequality here and solve for it symbolically. And so it looks like the only thing we need to do is to divide by -3. So let me rewrite this inequality. And so you have essentially the same inequality rules or equality rules. Whatever you do to one side, you do to the other, except when you multiply or divide by a negative number, your sign has to switch. So I'll have x over here after you cancel that out, and then 12 divided by -3 is -4. But I wanted to highlight this idea that we need to switch the sign when we're dividing by a negative. So the sign switch happens when we're dividing by a negative on both sides. Okay, so that is our solution, and this is the interval notation. We can write it in several other forms. We have x is less than -4, so it has to go with everything that's less than -4. So another way to denote that would be -4 and anything less going all the way up to infinity. And now the bracket over here is a square bracket because we are including -4. Alright, now the graph notation for this, or the graph solution, we have a number line. Because this is just an x, there's no y, so it's not a two-dimensional graph, it's a one-dimensional graph. And we mark off where -4 is. Again, you can use 0 as a reference if you want, but I'll just put -4 here. And let's do this with a slightly different color. We want to go from -4, and since we are including -4, we will fill this hole in. So it's a big dot, and anything that's less than that. So we would shade in anything that's less than that. And since we are going all the way to -infinity, oops, this is a negative. Let's put -infinity there. Since we are going all the way to -infinity, let's also boldface the arrow. So this is our graph. Now they asked us to use a graphing calculator, tables or graphs to verify your results. So I'm going to use the graph for my graphing calculator. Here's my graphing calculator, and I have it set up to include or put in some graphs. And so the graph that I want is, well, the two graphs that I want are -3x and 12. So if I put -3x here, and remember the negative for finding the opposite is different from the minus subtraction. So -3 times x is one function. The other function that I want is 12. So I'll arrow down here. Now y2 is just a constant function 12. Now I want to graph this, but I want to graph it so that I can see both graphs. And you can play around with a window if you want, but for me, I'm just going to go straight to zoom, and I'm going to look for zoom fit. I normally would go for zoom standard, but zoom standard goes from -10 to 10, and I see that I have a value of 12 here. That's not going to make it fit, so I'm going to keep going down, and I'm going to look for zoom fit. And here's zoom fit. I will click enter on that, and that's going to draw the graph that would try to fit the graph as best as possible. Now I want to find this intersection. First of all, I'll notice that the negative 3x graph is this diagonal and the constant graph is a horizontal line. So where they intersect is important, and furthermore we're looking for where the graph of the 3x function is greater than, so it's higher or on top of or it's above the constant function 12. So it looks like it's going to be less than going off to negative infinity here, but let's find the actual intersection. For that, I'm going to press second function and calculate, or the trace button, and then I'm going to select intersect. Oops, let's try that again. Second function, calculate, select intersect, that's the number 5. They want to know what the first curve is, that's y1, I'll press enter. They want to know what the second curve is, that's y2, I'll press enter. And then they want a good guess, and so I can move a little closer, but since these are two lines, it'll be an easy guess. It doesn't matter which one is which, so I'm just going to press enter again. And here is negative 4. And it looks like our, here it goes. Here's negative 4, and that's a negative 4 that we got, and we got x values that are less than negative 4, so all these x values that are less than negative 4 would actually work out. So that's how we can use the graph to confirm our results.